Removes excess water.
Yeah, that fluid, the excess fluid. Remember, arterial side, fluid leaves the capillary, venous side, fluid comes in. But the amount, volume of fluid that left is not equal to what came in, right? So less fluid comes in, so some of it has to be removed by the lymphatic system, right? So that's this number 2 spot, right? So we'll talk about that. We'll also talk about how lymphocytes are carried, not actually produced here, so I should change that. It's produced in it can mature within the lymphatic system, but it's produced in our bone marrow, right? Just like any other blood cell. And then provides immunity, right? So it has these lymphocytes and also has, in terms not just in our lymphatic vessels, but lymphatic tissues. There are other cells that are there too. Macrophages, which is smaller, whether it's whole red blood cells, for example, in our spleen, whether it's looking for bacteria and so on. So they have phagocytic cells too. And then this is kind of interesting. So lipids, digested lipids from our digestive system are not taken into blood. They actually go into the lymphatic system and then they go to blood, right? Whereas all the other groups, they're taken into the blood. Does anyone know where it goes first? What organ does it go first to? Is it to the heart or does it go somewhere else from the digestive tract? The liver, right? Anyone know the name of the blood vessel that goes from the digestive tract to the liver? Hepatic portal vein. Talk about this. That's going to take nutrient-rich blood from the digestive organs to the liver, right? Whereas everything besides lipids is taken that way. Lipids are taken by the lymphatic system, okay? And then, just like I mentioned about fluid returning back to the venous, here we join the blood, but won't be directly in the blood. Okay? We'll talk about it, we'll mention it here, we'll talk again in the digestive system about these specific types of capillaries found in the villi or small intestine. So let's talk about some organs and structures. Some of these are not organs, some are tissues within other organs, right? Lymphatic vessels, these are the ones that are transporting lymph, okay? So lymph and lymphocytes, they get transported by the vessels, while lymphocytes also sit and wait in lymphoid tissues or organs. What are some lymphatic organs? There's really 3 lymphatic organs. Not the liver. The spleen is one of them. Liver takes over if we have to take the spleen out. And it's one function, the filtering of blood part.
Good.
Lymph nodes are one too. They are actually little organs that spread throughout. They've got a capsule, so they are technically organs as well. What's the organ within our mediastinum? Thymus gland. Thymus gland also belongs to the lymphatic, as lymphatic organs, right?
Are the tonsils also part of that?
Those are the tissues. They are within the
Okay.
mucosa oral cavity. Those are also lymphatic tissues. They are organs, not in the capsule.
Yeah, I just wasn't sure.
Yeah, no, good point. We have some more in our intestines too, similar, called Peyer's patches and others. Good. Okay, so lymph is a definition for this interstitial fluid as well. It's very similar, it's just no proteins in interstitial fluid. Okay, so we remove all the proteins via analysis. So in terms of the lymphatic system, it's also considered a one-way system. It's not like our circular system. If we start the heart, it can come back to the spot, right? Without leaving the blood vessel. But in the lymphatics, you have to leave the blood vessel, the lymphatic vessels to get back in. Okay? So it's a one-way system. So in terms of vessels, similar to our blood vessels, we have blood capillaries. So here we have lymphatic capillaries, and they're going to get bigger and bigger. Okay, as they get bigger, they're just called vessels, and then trunk and duct. Okay, that's the biggest one, which we'll talk about in thoracic trunk, the right lymphatic duct. We'll talk about those are the two big ones. First, let's talk about lymphatic capillaries. So, in capillaries, is there blood flowing through both sides, if you will? Right, coming from the arterial side, going to the capillary, going to the venous side. Right, here it's a one-way. It's coming from interstitial fluid, then into the capillaries. Okay, lymphatic capillaries are very porous. What does that mean?
It's lots of holes.
Yeah, it kind of holds, it allows lots of things, very permeable, it allows things to move in, even cancer cells move in through our lymphatics, right? Especially lymph nodes and throughout our body too, right? What allows this is the way the vessel walls are lined. So if this was one endothelial cell, this is another endothelial cell, capillary, they're kind of lying next to each other. Here, they're actually lying over each other. So they can allow fluids to move through one direction, they won't let it come through the other. So they allow fluid into the capillary, but not out of it. So they act as mini valves. They're not exactly valves. Valves will be inside the blood vessel. Right? We do have in the lymphatics, we have valves too. Okay? But here, it's the endothelium itself that act as valves. So this is a nice image. This is from a different textbook. Okay, this is one cell. You know that this cell is lying on top of it. So fluid can go through this space. Fluid cells, large molecules can go through it, but they will not be allowed back into it. Okay? So they do have this overlap which creates a mini valve. Because they're one-sided, they need these collagen fibers to anchor them, to hold them in place. Okay? This way, fluids can move in, and any material, fluids, proteins, lipids, cells can move in, and then flow up into larger lymphatic collecting vessels. Okay? Proteins, cell pieces, pathogens, right? Whether it's bacterial, it gets spread by the lymphatic system, cancer cells spread by the lymphatic system. But they're not present in certain organs. So hence, if it spreads metastasis, it's not because of lymphatics, right? It's about blood that is spread. For example, bones, central nervous system, there are no lymphatic systems, so they have to do. And all of them will enter the blood supply. Lacteals are those special capillaries in the digestive or in the small intestine. They are specialized just to pick up the fat and then take it into the lymphatic circulation. Okay? They'll absorb digested fat. Okay, they'll take it along, and then just like any other lymph, they'll enter the blood supply right here, where the internal jugular vein meets the circulation. And that's we'll talk about that. So as these capillaries get joined up with other capillaries, they get bigger and bigger blood vessels, lymphatic vessels, right? They're very similar to veins, but these are even more thinner, and they have a lot more valves. They also anastomose. What does that mean? They combine, whereas veins do not do that generally. They just keep going up in one direction. But here, a couple of lymphatic collecting vessels will have connections. So unfortunately, this also will promote spread. But the idea is lymphocytes to be able to move through this without having to go back into blood circulation and then come back. Right? So this way they can still try and find those bacteria, find those foreign cells. So they'll do anastomose a lot more frequently. Here's an image. Let me see if I can show you. There's an anastomose here. This is one vessel. This is another one on this side, green. notice there's a couple of connections between them. So all of those collecting ducts eventually drain into two main vessels. Okay, it's the right lymphatic duct and the thoracic duct. There is no left lymphatic duct. But you have to think of it as a nice image. I don't think it was in our textbook here. This was a different one. It kind of cuts the body into like a quarter. So you'll see half of the head, half of the chest, and the right arm is draining by the right lymphatic duct, where the left head, left chest, left arm, all of the abdomen and pelvis, both legs will drain through the thoracic. Okay? So where does those fat-rich lymph, which duct will it be carried by? Thoracic duct, because where is it coming from? Digestive organs, which is in our abdomen. Okay? So thoracic duct will collect pretty much 3/4 of our body, even more if you really think about it. It's just the right head, right chest, right arm is by the right lymphatic duct. Everything else is by the thoracic duct. Okay. Both of them similar points of entry into the blood supply. There's the internal jugular vein. It will meet the subclavian. Subclavian meets below the clavicle. It's coming from the arm, meets that spot. That's where the lymph will join the blood supply back to the circulation of the organs. Okay? So right side will be the right lymphatic duct drain. Again, remember when you're looking at an image, this is the right side, this is the left side. Unless others state that, it's always been looking at somebody else looking at you. Right? So this is the right side. So this is the right side, this is the left side. Okay. The thoracic duct will join by the left subclavian vein, means the left internal jugular. And then it goes into venous circulation. Any questions? Okay, let's look at so it's circulation, right? Let's look. Oh, lymphedema I mentioned, right? If we have the blockage of this lymph vessels, fluid will back up into that portion of the leg, arm region, and then it will go into or will back up into the interstitial fluid, right? Nothing will be collected, it cannot be moved because it's a blockage. So if I had some sort of growth that blocked my lymph vessel coming from my left arm, the left arm can swell up with lymph because it's backing up. This can be pretty serious as well, especially with cancer patients. The breast cancer and lung cancers, a lot of times metastatize to the lymph nodes here. If they're large enough, they can block lymph vessels. So lymphocytes, this is the main cells within lymphatic vessels. Lymphocytes, we have 3 types of lymphocytes in lab. We'll talk about them. There are 3 main types of lymphocytes. One is called a natural killer cell. This belongs actually to our innate, okay, or non-specific immune system. We'll talk about specific versus non-specific. And then non-specifics are innate, inborn. Adaptive is the more specific. It's towards one type of bacteria, one type of virus, one type of cancer cell. Okay? So this is non-specific. These 2 belong to our specific. So it's the second most common white blood cell, right? What's the most common white blood cell? Neutrophils, right? We all saw neutrophils. So we'll talk about T cells first. Okay, T cells, there are 3 main types, and then the memory just basically is stored kind of a cell. Okay, so cytotoxic T cells, they're the the main role when we think about the fighting cells or T cells, they're the ones which double. Okay? They will destroy the cells. We'll talk about this on Wednesday. They do two things. They're going to bore a hole in the cell membrane, which promotes fluid, extracellular fluid, to flood into the cell, and it also cause the lysosomes to burst open. What do you think that will do? Yeah, so lysosomes contain enzymes that will digest from inside out. That's what cytotoxic T cells will do. They'll actually break down the cell. Okay? While T helper cell is very important, okay, they not only help T cells, they also guide and stimulate B cells, right? Does anyone know of an illness which attacks T helper cells? HIV, the virus attacks T helper cells. They're also called, does anyone know the other name by which we refer to the T helper cells? It's a short symbol, but we can say it's not 3 letters. So, CD4 count, that's for T helper cells, right? HIV will damage these, it'll start killing them, which means both T cells and B cell activity will be reduced. When we have AIDS, that means the activity is really bad, really low, that we have this immunodeficiency. What does AIDS stand for? Not it's acquired immunodeficiency syndrome. Right? It's acquired because the virus that's infected the individual is causing. We'll talk about this in the next chapter. That's the most common incorrect autoimmune disease. What is autoimmune disease?
The immune system attacks your body.
Yeah, our own immune system attacks our immune cells. Right? We also have, it used to be called suppressor T cells. We really call them regulatory because they kind of like the gas controller. They'll say, okay, now you need to speed up your activity. There's not enough activity. But if it's too much, they'll say, okay, now you need to slow down. Previously, they only knew about the slowing down part, but it does play a role in regulating. So that's the more correct term, regulatory T cells. They will control the activity because we don't want too much immune cells to flow, immune activity to take place, because they'll just use up the body's immune system and then we can potentially shut down. Okay, and then whatever got activated, some of those T cells become memory T cells, and we'll talk about the importance of it. This is the principle. We'll look at it more of the B cells. It's easier to show and prove, okay? But it does increase our response the next time. Faster response, quicker response, as well as a much stronger response. So we'll talk about those things as well. The B cells, does anyone know why it's called T and B cells? Besides how it functions, but more why did they decide to give it a T and a B? Close. They all come from the bone marrow. But where they mature, we'll talk about that, right? So T cells mature in the thymus gland, whereas B cells mature in the bone marrow. Okay? They mature there. So these ones are the ones that will be producing the antibodies, right? They are, once activated B cells, they will be called plasma cells. Okay, and the function of plasma cells is basically to produce these antibodies. Where are antibodies found? Is it on the cell membrane? No, it's in what part of the blood? Blood plasma. So that's why the name says plasma cells. Okay, it's not just because it's found in the blood plasma, it's found in blood, but because they contribute the contents of blood. Like antibodies are parts of it. These are activated B cells that now their job is just to produce antibodies, okay, against what activated them, against a specific antigen, specific bacteria, virus, or cancer cells. Okay. Antibodies are proteins. We'll talk about them. We have 5 different types of immunoglobulins. 2 of them are antibodies. The rest are not antibodies. We just say, well, I guess 3 are secretory antibody too. So they basically, you can't say they destroy antigen, they bind to it, right? In lab, we kind of use them. What do we use them to demonstrate? Antibodies, what do we use them for? Titrate, right? What do they do to red blood cells? Agglutinate. What does agglutinate mean? They clump together. They didn't destroy that antigen. It's basically clumped together. We'll talk about a little about it. What happens when antibodies and antigen bind? What that means. Okay. But antibodies basically bind to that. They can inactivate them. They can agglutinate them. They can cause macrophages to say, okay, this is what you need to destroy the swallow up these cells and so on. They don't directly influence or they don't break down the antigen. That's the right While natural killer cells, these are part of our non-specific. Okay, so we'll talk about this tomorrow. We have a first line defense. We stop anything from coming into our body. Okay. Second line defense, it's in our body, but it's non-specific. It'll just grab onto any virus, not just a specific virus. Okay. Natural killer cells belong to that second line. They're inside our body, they'll grab onto virus-infected cells and cancer cells that can destroy. Okay. But they're part of our innate or non-specific immunity. Okay, so they'll destroy virus-infected cells and cancer cells. We do have the third line too. That's going to be our T cells. T cells will also attack, cytotoxic T cells will also attack virus-infected cells and cancer cells, but it's going to be specific. So one T cell will recognize one of them, it will not recognize all of the cancers. Whereas natural killer cells will just recognize cancer cells being cancers and just destroy any cancers. And what's the definition of cancer? Uncontrolled growth, right? So multiplication, uncontrolled. How did it come about? Yeah, it's a mutation in the DNA. So in terms of lymphatic system, we have lymphatic organs and lymphatic tissue. Here it's talking separately, but it's considered a organ because it has a capsule surrounding lymphatic lymph nodes are also considered part of it. We have more concentrations here. It's spleen, thymus, and the lymph nodes are organs, while tonsils and other lymphoid tissue, including appendix, right? Those are lymphoid tissue within organs. They play a role in the lymphatic system. So let's talk about these nodules or these tonsils or other stuff, right? So in terms of the collections, the lymphoid collections, sometimes they're called nodules, or I remember now why. Some of them have sort of a capsule. They don't have a complete capsule. They'll say, okay, this is where we are going to stay. We don't go infiltrate. We actually kind of wait for things to pass through us. Okay? We find them in our respiratory tract. We try and grab onto the bacteria. We find them in our urinary tract. We find them in our digestive tract as well. Okay? So our bacteria, normal flora, fine in there, but if it gets into our blood or other organs, it can cause problems, right? So they're spread throughout. So one of them is Peyer's patches. These ones we will look at in the digestive lab. They are in the mucosa, some mucosa part of the digestive tract. Right? So hence, it comes in. Before it can go further, these hopefully will grab onto those inflammatory cells in the intestines. And then we also have the appendix, basically. These are pretty much purely lymphoid tissue. In us, we don't really have a necessity for it. It's really useful in herbivores where they have a larger cecum, and appendix is necessary because food stays in there a long time. It's bacteria which helps to break down. What can they break down that we can't break down? What part of the plant material can we not break down? Humus. Can we break down starch? Yes. What can we not break down? Not exactly. It's just a pigment. What makes those fibers? It's the cellulose, right? So cellulose is the material that we cannot break down. While herbivores that only eat plant, they have a long, we talk about the cecum and the appendix because they're spending a lot of time there. The food does, we do use bacteria to break down, so we don't want the bacteria to get into the product. So we have a lot of use for the appendix because the bacteria is spending a long time in there. So let's talk about tonsils. Yes, normally what we talk about tonsils is only one type of this tonsil. A tonsil basically means it's a lymphoid tissue found around oral or nasal pharynx. Okay? Oral cavity and the nasal cavity in pharynx. Okay? Because the ones we call tonsils, the actual name is pharyngeal, palatine tonsils. Okay? Palatine tonsils. Where is our palate? Hard palate, soft palate? Top of the roof of our mouth. Which one is this hard palate? Anteriorly behind is the soft palate, right? So just behind the soft palate, or kind of anterior but more medially to the oral cavity, that's our palatine tonsil. That's what we generally call tonsils. But in our nasopharynx, we have what's called the pharyngeal tonsil. You might have heard of adenoids. That's the non-scientific name for the instruments. Okay, if adenoids swell up, they can. So this is the nasal cavity. Nasopharynx is part of this tube. Pharynx at the top. Okay, so the pharyngeal tonsils there. If it grows, it can block the air pathway. Okay, so sometimes we treat that tonsils, recurrent tonsillitis, we may take it out. Okay. And then we have lingual tonsil, which at the, what does lingual mean? Tongue, so it's at the base of the tongue. Okay. So we have palatine tonsils on either side of our oral cavity, the back of the oral cavity, posterior oral cavity, pharyngeal tonsil within the nasopharynx, and then the base of the tongue is our lingual tonsil. They're trying to protect entryway to our digestive and respiratory tracts. So next is the organs, right? Lymph nodes, thymus and spleen. So they have a fibrous capsule that's surrounding each. So lymph nodes, we have them spread throughout our body. Just bear with me a little ones because we've fallen a little behind. Please finish lymphatic about 4 or 5 slides. We have them spread throughout. When they're not enlarged, they're only about 2 centimeters, but they can be quite large when they enlarge, right? So we have a fibrous capsule surrounding. It looks like a pea, like a kidney. There is a little hilum, okay, which the vessels do leave and enter. In terms of how fluid flows through it, okay, it comes in as afferent vessels and then leaves as efferent. What's significant is we have a lot more afferent vessels compared to efferent. What would that do? Yeah, the flow will be slowed down, right? Because the idea of lymph nodes is to have this high concentration of this immune cells sitting and waiting. So when the lymph flows through, we want to be able to actually test the fluid out or the contents of it out. Okay? So there's a lot more afferent vessels compared to efferent. This ensures that it slowly moves through the lymph node so we can pick out all those bacteria, the viruses, the cancer cells. And these are spread throughout the body, right? Some come very superficial, but otherwise they are deep as well. Right? So they filter the lymph. Okay, don't try to remove anything. We remove these lymph nodes do a great job in removing most of the things, right? And they will also stimulate T cells and B cells. They will activate them. They also stimulate. In the thymus gland, located in the superior mediastinum, the main function is to tease lymphocyte maturation. Okay, that's the highlight. T cell maturation occurs here. Next part of this chapter, we'll talk about it on Wednesday. What does that mean? Okay, what does that mean? Mature T cell maturation. As we were small, it did increase. Okay, at puberty is the highest, then it actually starts to shrink down. Okay, so if we had a scan, X-ray showed a large thymus gland in adults, usually there's something else going on. We shouldn't see a very large thymus gland, it should be a smaller thymus. So it's located in the mediastinum. What's the function? T cell maturation. We'll talk about what that means tomorrow on Wednesday. The last organ is the spleen. Okay, spleen is the largest of the lymphatic organ. Where is the spleen located? Left upper quadrant. What's the regions? What's that area called? Left hypochondria. It's tucked in under our rib cage on the left side. Okay. Here, mostly what's being filled, it is actually filtering just blood. Okay. This is one that can filter blood. It's going to remove some things in blood. It's also looking for any foreign organisms in blood. Okay. There is areas, we'll talk about it, there's areas that are mainly waiting with T cells, right? This is called the white pulp, and looks similar to other lymphoid tissue. And then we have an area called the red pulp. It's again not one spot, many spots. But that's mainly to filter the blood cells inside, right? So all red blood cells are broken down in this spleen. Okay, break down the red blood cells, recycle the iron. Here's what it looks like. So white pulp, that's really lymphoid material, lymphoid tissue. Red pulp, just mainly blood cells waiting. Macrophages will sample the blood cells, make sure they're so good. If they are worn off, they'll break it down. What's the lifespan of red blood cells? 120 days. It's the spleen that will look for all red blood cells and break it down. Okay. So red pulp versus white pulp. White pulp is concentrated lymphocytes. Whereas red pulp, red blood cells, and macrophages. Questions? I wanted to get to it today. Thank you for